Hello and welcome to this tutorial. Now we see on how to bring more of an EBFM perspective to mixed fisheries simulations and how to use this to derive MSFD indicators. This work is part of the European Union Horizon 2020 research project called CWISE, and it was work conducted under Work Package 4, the ecological effect of fisheries. So suppose you have an FLBEIA model where you simulate the mixed fisheries situation in the North Sea, and now you want to put it in a wider ecosystem perspective and know what are the impacts of your simulated harvest control strategies to the ecosystem. And here we want to combine ecosystem-based information with our mixed fisheries simulation. So we work with the FLBEIA model output, we derive the important MSFD indicators directly from the output or add accompanying data, and we try to visualize the results and compare the respective harvest control strategies. So first, in order to do this, we need to set up our R, install the relevant packages, and download the data I prepared for you under my Fixture account, where you can download a zip file and extract the relevant input data. And then we use the FLBEIA output to produce our MSFD indicators. So the output contains a series of scenarios, 4 management scenarios called status quo, FMSY, PGY, and case study. FMSY min, PGY min, and case study correspond to a landing obligation scenario under different fishing pressures and different type of implementations, whereas the status quo scenario is more a baseline scenario where we simulate the recent effort up to the future. And those management scenarios are paired with some climate scenarios, the well-known RCP4.5 and RCP8.5 climate projections, and an OCC baseline that's just the RCP4.5 scenario 1 with the median trend removed from it. Now we also need some helper functions to reshape our output a little bit and derive our MSFD indicators. So we focus on 4 indicators, so descriptor 1, 3, 4, and 6, and I will just go briefly over those which we focused on. So the first indicator we calculate is the bycatch of pet species, so the ones that are especially vulnerable, and we focus on the harbor porpoise here. And what we do is we use the relevant gears that catch harbor porpoise and try to scale the effort and the individuals caught in a specific data year, 2020, with the effort of those vulnerable gears that are simulated forward in the future, and see what might be the relative bycatch compared to the past. Then the D3C3 stock health indicator focuses on the average stock or spawner age, being an indicator for the age composition within the stock. And here higher values indicate a larger proportion of older individuals within the stocks, which is generally considered more healthy because it produces higher rate of viable offspring per capita. And so it's beneficial if this indicator is high. Another indicator we calculate is the D4C3 large fish indicator, where also higher values correspond to a better system. And the last one would be the effort contributed or exerted on the sea floor, where we calculate the RBS indicator. the way the RBS indicator is calculated is written down in another tutorial. Here we focus on only bringing in the RBS indicator calculations with the FLBEIA model, which was done before, and we just visualize what comes out here. Okay, now we brought everything together and want to visualize it, and this is just a snapshot of those indicators. So our FMSY min scenario seems to be performing best in terms of bycatch of porpoises, whereas the status quo is the worst. Also, status quo is worst for the average spawner age. Here, higher is better, and the large fish indicator is also worst in status quo scenario. So here on the ecological effects, the FMSY min landing obligation scenario seems to be one of the better performing scenarios that we simulated. And looking at the RBS threshold, we also see that choosing an average RBS threshold of 0.8 seems to be quite okay, and a lot of benthic habitats are in a good status, here depicted in the bluish area, whereas only a few are worse in the current situation. But it can also change depending on how you depict your threshold. So that's it on the tutorial on MSFD indicators, and I wish you a good day and goodbye.